Hello everyone, welcome to You Can Automate. In this session, we are going to learn how to store embeddings in the vector database. As part of the vector database, we are going to use a quadrant database and we are going to write a code to store the embeddings in the vector database. Let's start with that. In the previous session, we have learned how to generate the embeddings. If you have not watched the previous session, the link is given in the description. You can go and watch it so that you will have a continuity on this session. In this session, we are going to cover these topics: what is quadrant, why it is used in a RAG, how to set up a quadrant database using Docker, how to store embeddings in a quadrant vector database, and all these topics we are going to learn, and we are going to write a code to implement these concepts also. So let's begin. So the first thing is, what is quadrant and how it stores embeddings. Quadrant is open source vector database designed to store, index and retrieval high dimensional vectors, that is embeddings. It is optimized for similarity search, making it ideal for RAG, semantic search and AI applications. Let's take an example. You are sending a documents here that could be of any of the form, and it goes through a chunking. It generates a different chunkings and then it generates embedding models. Once we get the embeddings of any of the given input, that is nothing but the numbers, that has to be stored in one of the database. The database is nothing but the vector database, and here we are going to use one of the vector database, that is quadrant. This quadrant database stores embeddings with the metadata. Metadata here, it is nothing but the payload. Why it is stored as form of metadata is for fast retrieval. How this works is, for example, if as a user, if I'm asking any query, first user query will be generated into embeddings and then it goes through similarity search and then relevant results will be returned. So assume I'm asking a question like what is quadrant, and all the results, whatever it gets, it from that results it will fetch top 3 and from that it will return the best answer. So in this session we are going to focus on a quadrant, how to store embeddings in the quadrant database. In the quadrant database, we call it as a collection. Data is stored in the collection. This is nothing but exactly similar to a table in the regular database. Collection name could be any of that. It could be related to documents. Here each document is represented in a form of a point. It is called as a point, and each point will contain unique ID and the embeddings, whatever embedding we have generated in the previous phase, that we will store it inside the point, and some of the data, metadata, we will store it. We'll see in detail like what this payload contains. So unique ID could be anything. Here we are using one of the library to generate the unique ID, and that we are assigning to this unique ID here. After that, whatever the embeddings we have got, and that embedding could be of any dimensions. Here we are using one of the embedding text that is generating the embeddings in a form of 768 dimensions. That embeddings will be stored here, and then payload will contain the text. It is to have some pair, what is the text and what is the embedding it got generated. That is nothing but the chunk. So text we will save as it is, which is coming from the document, and we'll mention what is the source here, and some category details also we will mention what category it falls under. So all those details we will mention in the payload. Similarly, that payload will be created for all different chunks. How similarity search works in quadrant is, user is asking some query, that query will be also converted into embedding, and quadrant similarity search, anyway the inputs what we have generated, that will be stored in a form of quadrant, and this it will match whatever the embeddings we have generated from the query, and whatever embeddings which we have it from the input, that will be matched, and then it will send the relevant answer. That we'll see in detail like how this searching happens and how we are going to retrieve everything future sessions. So the next thing is how to set up this quadrant. So quadrant can be set up using a Docker. If you are using a MacBook, you can use a Ollama. If you are using a Windows, then you can directly use a Docker desktop. I'll be using a Ollama. And if you are on Windows machine, then you can follow these steps. It is exactly the same steps, you can follow it. Here first thing is I need to install Ollama. To install the Ollama, I'll be using a brew command. Brew install Ollama Docker here, and my Ollama is all now. The next thing is I need to start this Ollama. So to start the Ollama, this is the command which is given in this slide. Ollama start CPU, and I need to provide the memory. So let's go to terminal and execute this command. Ollama start -CPU -memory 4. Okay, looks like spelling is incorrect. Let me correct this again. Okay, Ollama is started now. So now my Docker is running. Let me run a command docker ps to check whether Docker is running fine or not. The command is docker ps here. So docker ps, yes, my Docker is running fine. As of now, there is no image, there is no container running. That's why it is not showing anything. Next thing is I need to pull one of the image that is related to a quadrant. So pulling the image is the command docker pull quadrant/quadrant. So this is pulling the image which is quadrant image. Yeah, image got pulled here. I need to run this command to create the container. So what is the command? Docker run -d and --name quadrant -p. Here I need to provide the port here. 6333 is my port and name will be quadrant. This is the name which I'll be giving it to my container. So now if I run the docker ps, I should see a container ID and the name of that container, that is nothing but the quadrant. So here my container is running. If I go to this URL, that is localhost, I should be seeing my quadrant running. So let me open the localhost here. Localhost and the port is 6333. It says that quadrant is running fine. And if I want to see the database, I need to add the dashboard here, so that I'll be seeing quadrant database. This is how the UI looks like of the quadrant. I will provide this link in the description. And as of now, there is nothing in the collection. That's why it is showing empty. So once we add the embeddings, it will have some data in this. So here first thing is in the requirement.txt, you need to add the quadrant client. This is required to implement all the quadrant related code. So I have added the quadrant client as a library. I need to install this quadrant client in my environment. Then after that, if you go to config.yaml, here I need to define what is the host and the port which I wanted. Directly go to config.yaml and add quadrant. Here I'll be adding a host, port and collection name. This port 6333 is coming from the Docker container which I have triggered. If you run docker ps, it will show the container and which port it is running. You can copy that port here in the config.yaml. And this collection name is like what is the name of collection which you want to store it with in the quadrant. So I'll take this HR policy, the name exactly file name as my collection name here, and I'll say that HR policy is my collection name in the quadrant database. So here I need to add a vector size also. What is my vector size for this nomic embed text which embeds in a 768 dimensions? That's why I need to provide 768 here. So let me go to rag utils now. Let me add a vector store as a new file. Here I'm going to write a code to implement this vector storage. Let me import all the required libraries. First I need to import from quadrant client. Then I need to import from again quadrant client STP to make all for different models, and I need to call the methods. So here I need to import vector params and distance, then add the import of UID, and here my method will be to set up the collection. So this particular collection will take client as an input, collection name and the vector size as a input for this function, and the client dot recreate collection. In this I'm going to pass the collection name first, and what is the size, vector size which I wanted, that I'll be sending, and what is the distance. Distance is nothing but the 768, right? And distance dot cosine is the what we have learned before. It is going to use a cosine similarity method to store all the embeddings. So here my setup collection method is done. Once setup collection is done, I need to inject all the embeddings whichever I have got it into the embedding. So here I'm going to write a new method, that is diff ingest chunks, and this will take client, collection name, chunks and embeddings as a parameters. First here I need to create points. So here we are going to create a points. We are storing all the vectors in form of points in the database. So I'm adding a for loop here for chunk vector, and I want to pair chunks and embedding together. That's why I'm using a zip here. And then I'm adding a points dot append, and in each embedding I want to construct a point here. This is how I'm going to construct a point. This particular method will take ID. This unique ID will be added for each point, and in this I'm sending a vector and the payload. Payload contains text and chunk. After generating the points, I need to upload into a database. For uploading, this is the method I'm using, client dot observed, and this method will take collection and all the points which I have created. So here my step 4 will be, first I need to connect to a quadrant. To connect to a quadrant, I'll be calling the method quadrant client, right? And in this I'm going to pass all the details, what all the config details which I've added in the quadrant, that I'll be sending here. This quadrant client will take two parameters. One is a host and the port. The host is coming from this config which I've created, that is a local host, and the port is nothing but the port which is coming from the config 6333. This is the same port which is showing in the Docker container execution also. So I'll be using the same port here in the code while creating a client. So once client is created, I need to create a collection using that client. This is what I have created method setup collection. This will take three arguments: client, collection name, and a vector. So I'm calling this setup collection method, passing the client and config details, the collection name and the vector size. So all this data is coming from config, and config details are added here. So once I create the setup collection, now I need to inject the chunks. I'm going to write a code for injecting the chunk into Qdrant database. This inject chunk method will take parameters like client, collection name, chunks, and embeddings. All these four parameters will go into inject chunk. Our inject chunk method is ready and we are ready to run. Before that, I need to check the Qdrant database, whether Qdrant database is properly set up or not. So let me go to Qdrant database and see. So this is a Qdrant database and collection is empty as of now, and if I run this, all the data will be coming here. So let me run the code, python ingestion.py. So it has generated all the chunks, it has generated all the embeddings. Now it says that data ingestion is also complete. So let me go to Qdrant database and see that whether it has got all the data or not. So let me refresh this Qdrant localhost. This is the policy or the collection name which we have given, and the status is green. It has generated 13 chunks. 13 chunks came here into the collection, and it has got two segments, and it says that 768 is a dimension or the vector size which we have given. If I click on that, it has generated all the chunks, and for each chunk it has generated a unique UUID, and this unique UUID is coming from the code which we have written while setting up the chunks, right? This is where you are sending the UUID, and this is the text which it got generated. This payload is nothing but which we have created, contains the text and the chunk. This is the entire chunk which it got created, and this. So if I go and search the appraisal word which is there in the starting, this is how it looks like. It is starting from appraisal keyword here. It is ending at 30 day. 30 day is the last ending word. If I scroll down, yeah, this is the chunk and this is the vector DB it got generated for, and this is what it stored in the vector database. Now let me go to the second chunk. It is starting from page 2. Words is that recruitment. Let me scroll down and see where this recruitment is there. Yes, this is the heading of the page 2, and this is the starting point of the second chunk, and it is ending at somewhere permanent employee. This is the last word, and let me go and search the permanent employee here in this document. Yeah, permanent employee, here it is. So this is the last word of it. So this is another chunk. Like that, all the chunks will be generated, and all 13 chunks are represented here. All it has got the vector embeddings. Let me check another chunk. This is related to a leave policy. If I go and click on open graph, this is how the quadrant, this is how the vector embeddings will be displayed for any of the chunk. This is about the timings and different leave types and how many leave types we have. And if I hover on another embedding, this talks about the paternity leaves, how you need to submit paternity leaves. All the details about that paternity leave is connected to this leave embedding. There is another embedding, and this embedding is talking about some of the other policies, that is what is prohibited and some of the employment categories, full-time employees, part-time employees, all the policies which are related to employee is connected to this embedding. Like that, it has got a different embeddings. All are which are nearby or which are related are shown here as a connection. So if I go and click on each embedding here, it again shows that which is the nearby embedding for that. If I click on another embedding like that, so it should open all the connected embeddings for each embedding. So if you count all these embeddings which are generated here, there it should have a 13 embeddings. That is nothing but the 13 chunks. For each chunk, some of the embedding got generated here. So this is about how to store embeddings in the vector database. I will provide the entire repo link in the description. You can go and check it. And if you take a look here, We have completed all 5 steps in the ingestion phase. Try this and let me know if you have any questions. In the next session, we are going to see how to retrieve these embeddings and do a search. Thank you.